Okay, so are you ready to get a little bit smarter in mathematics? Well, actually, a lot of you out there watching this video are pretty sharp in math, and I think this is going to be a easy problem for you to solve. Matter of fact, let me go ahead and read the problem. It is you are in the corner of a 40-foot square room. What is the distance to the center of the room? All right, so if you can figure this out, go ahead and put your answer into the comment section and feel free to use a calculator. Matter of fact, a calculator is highly suggested for this particular problem. Now, I'm going to show you the right answer in just 1 second, and then, of course, I'm going to explain the solution to this problem. And as I explain the solution, I'm going to kind of show two approaches. I'm going to take the approach that most of you are probably going to take to solve this problem. Then I'm going to show you a very important geometry shortcut. Okay, now I'll kind of hold off on giving any more hints on what I'm going to be talking about because I want to give you a full opportunity to solve this problem. But this is going to be a formula, a shortcut that you're going to want to know. All right, but before all that, I'm going to go ahead and quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy it, make sure to hit that like and that subscribe button because that really does help me out. All right, so let's go ahead and take a look at the answer. Again, you're in the corner of this 40-foot square room. How much do you have to travel to get to the distance, what's the distance, or how much do you have to travel to get to the center of the room? Well, if you did this right, you would have come up with about approximately 28.28 feet. All right, now if you have another decimal, but you're pretty close to this answer, I'm going to assume you did this correct, and we have to celebrate by giving you a nice little happy face and A plus a 100% and multiple stars so you can brag to your friends and family that indeed you are a certified professional expert in the area of solving right angle word problems, okay? And that's kind of what we're going to be getting into here. I'm sorry, this is a right angle, but really this is a right triangle word problem, okay? So we're talking about right angles, but specifically we'll be talking about right triangles, which is going to really lead us to exploring what we call the Pythagorean theorem. And here it is right here. A squared plus b squared is equal to c squared. This has everything to do with right triangles. So this problem here is really a right triangle word problem again, and we're going to need this all-important theorem to solve this. Now, hopefully most of you out there have seen this before. A squared plus b squared is equal to c squared. If you haven't, well, this is probably one of the most important formulas in all of geometry. Matter of fact, this formula, in a lot of ways, is kind of the foundation to trigonometry as well. So it's not that difficult, so don't let this notation scare you. Matter of fact, let's go ahead and get into the problem right now. All right, so we are dealing with a math word problem, and it's always a good idea to read any problem or do any problem you're facing, even outside of math, to think about the problem and just don't read a problem or don't look at the problem one time. Stop and pause and think. So I always like to use the rule of three. Read the problem at least 3 times. Make sure you understand what the question is. So here we have this square room. We're in the corner, and how far is it to the center of the room? Now, one thing about math problems, okay, things that you'll find on homework, tests, quizzes, exams, is sometimes, students or people can kind of look too much into the problem. Okay, you're going to have to simplify or just assume the simplest version or interpretation of the problem. Okay, so in other words, don't be like, well, what if I'm standing in the corner and my foot's like right here and my other foot's right here? Or, you don't want to kind of do that. You just want to say, all right, look, they're kind of clearly asking me here, what's the distance from this point in the corner to the center, right? So you always kind of just want to simplify things. And I don't think any of your math teachers would, be upset at you for doing that because that's how these problems are kind of designed. All right, So now that we, read the problem, what we want to do is try to model the problem, right? A picture is worth 1,000 words, and when you can kind of see the problem, oftentimes it's much easier to identify the solution. And what we're doing, what we're dealing with here is a geometry problem. So let's go ahead and model what's going on by coming up with a nice, lovely sketch. All right, so here is a square room, or my little sketch of a square room that's 40 feet by 40 feet. And here I am in the corner. So I'll put myself right here. Now, the question is, how far is it from the corner right here to here? Okay, well, let's just make sure, first of all, you understand what a square is. Now, some of you might be saying, well, I know what a square is. Well, let's just quickly review. So the first thing that most people know about a square is that it is a four-sided polygon. It kind of looks like a box, right? And all four sides of this box, this square, are equal. Okay, so that's very good. Now, equal measures in geometry, we use this other word called congruent, right? And then you don't have to use that word, but it's a good word to know, congruent. So opposite sides or all sides of this square are congruent. And the notation or the symbol for that is this right there in geometry. Again, you don't have to know that, but just these are little bonus tips that I'm kind of throwing in there. Okay, so that's the first thing that you need to know about a square. But the second property about a square is that the angles in a square are right angles. Okay, all these angles right here are right angles. All right, now what does a right angle mean? Well, a right angle means that these angles are 90 degrees. All these angles here are 90 degrees, and the sum of the angles in a four-sided polygon, i.e. a rectangle, a square, etc. If you add up all four sides, they'll always be 360 degrees. That would even include things like a trapezoid as well. All right, so that's going a little bit beyond here, but these is, again, some bonus tips, but you need to know that all four sides of the square are congruent, i.e. equal, and really importantly here is that all the angles are 90 degrees. So what we want to do is say, okay, well, I have 90 degrees here, 90 degrees here. What can I do? Well, this problem to get to the center right here is, well, first of all, let's just identify where is the center of this square. Okay. Well, to find out where the center is, we have to basically intersect the diagonals. Okay. So from here to here, if I can kind of continue on, this line is called a diagonal. Okay. Now, if you drew another diagonal from here to the right through here, are going to pass through the center of the square. Okay. So another way, I guess you can determine it. Not guess, you could. You can say, okay, well, here's 20. If this is 40 feet, I can go 20 feet here, and then I can go 20 feet here, right? And then I can just kind of intersect that point right there. Okay. But again, you're not positioned, you're not positioned right here at 20 feet. You're like, oh yeah, I just have to come out this much and I would get to the center, right? Well, no, that's not the case. You're in the corner. So we're going to have to interpret this problem and think of it as a triangle problem, right? Now, if you kind of see here, this right here is a triangle. So let's start thinking about this problem in terms of a right triangle. All right, so I did use this word right triangle because we are talking about a square, and we know that all the angles here in the corner are 90 degrees. So this type of triangle in geometry is called a right triangle. It's very, very important for you to understand how to solve right triangle problems. Matter of fact, I'm going to give you some uh, formulas here. Well, actually, we're just going to talk about one formula. In particular, I'll give you another formula a little bit later in the problem. But the formula that first going to give you here is this formula here. Okay, and this particular formula is really what we call a theorem, but that's really not so essential. This is the world famous Pythagorean theorem. A squared plus b squared is equal to c squared. If anything else from this video, okay, just make sure you say, oh, you know what? I learned about this little theorem, this formula right here. Now, this theorem, okay, this formula, okay, this law, geometry property law, however you want to think about it, pertains to right triangles. Okay, right triangles only. So in other words, when you have a right triangle and a triangle where one of the angles is 90 degrees, then you can think of the Pythagorean theorem. Okay, so what does this thing tell us? Well, it's basically a relationship between it establishes the relationships between the lengths of the sides of a right triangle. So let's go ahead and just quickly look at the sides here. Now, the first thing that you want to understand about a right triangle is that the longest side of a right triangle is called the hypotenuse. Okay, the hypotenuse. So it's always it's pretty obvious. It's opposite of the 90 degrees. You'll see, oh, I have a right triangle. The longest side is called the hypotenuse. And in terms of the Pythagorean theorem, that is going to be the length C. That's always length C. So length C in this theorem is always the longest side. Okay, so if you remember that, then these other two sides right here, we just refer to as the sides. So we could call this side A, call this side B, or vice versa. That doesn't make a difference. Or this could be A, this could be B, but the longest side always has to be C. Okay, so how does this thing work? Well, let's go ahead and talk about that right now by showing you a lovely example. So what the Pythagorean theorem states is that if we take the square of this side and the square of this side and we add it up, it's the same as the square of the hypotenuse. And this is a little bit easier to actually see in action to understand the Pythagorean theorem. So let's take a look at our square here. So here, this is 2. Okay, this side would be 2 because all sides are equal. This side is 2. So let's suppose I wanted to find the length of the hypotenuse. Okay, and of course, we're going to want to do that to solve our problem. So how does this work? Well, what we're going to do is we're going to plug in the lengths into this formula. So 2 squared, okay, which would be this side, plus another 2 squared, which is b, is equal to c squared. Now, I don't know what c is, so we'll just write that as c squared. All right, so what is 2 squared? That is, of course, 4, and this 2 squared is 4, and that's going to be equal to c squared. So 4 plus 4 is 8, so now we have this equation, c squared is equal to 8. So to determine or to figure out what the actual length of c is, what we need to do is to solve this quadratic equation and just take the square root of both sides. Now, for those of you that are really up to speed on your algebra, this is a quadratic equation. It will have two solutions, a positive and negative, but because we're talking about distance, we'll just kind of deal with the principal square root, just the positive version of this. So I could go into my calculator, take the square root of 8, and that would be this distance right there. Okay, now I'm not going to do that just yet because we're going to use everything that we learned right here to solve this problem. And hopefully most of you now can just kind of figure out what I'm going to do now that we kind of covered the Pythagorean theorem. So let's go ahead and do that now. But before we do, I would like you to do something, and that is to subscribe to my YouTube channel. This really, really helps me out, but it really helps me help others, okay? There's a lot of people out there that are just interested in math. It keeps their brain sharp, or they just like the topic. And I love that. I love to, entertain you or teach you, review things that a lot of you probably forgot. I love that. Okay, that really, makes me happy, and I'm really sincere when I say that. But there's also so many, a vast majority of people that really struggle in math that don't need to be not, don't need to struggle math. Unfortunately, okay, it's a major problem that's going on. Is a lot of classrooms just don't have enough qualified math teachers. Not saying they're not good teachers, but to teach, for example, at the high school level, in most school districts, you have to have a degree in mathematics. That's a pretty tough degree to get. I have a degree in math. I have a master's degree in math technology, or sorry, educational technology. But what I want to do is share all those years and years of experience with people and give them hope and encouragement to learn. Okay. Now I know that's a long, rambling request to get you to subscribe, but I want you to understand the importance of what I'm trying to do. Okay, so if you are a subscriber, thank you so much. And if you are really struggling in math, okay, this message is directed towards you. Please do not give up. Okay, with clear and understandable instruction and support, you can really learn this stuff. Okay, and make sure to hit that notification bell as well. And thank you for being patient and let me kind of blob here about why it's important for you to subscribe to my channel. Now back to the problem. Okay, so here is now the situation. We have our 40-foot room, and we want to get to the center of the room, okay, which we now know is along the diagonal, okay, which is the hypotenuse of this right triangle. Okay, so hopefully that is clear, and if it wasn't clear, now it is, right? So the center is along the hypotenuse of our right triangle right here. So what would be our strategy? Well, we're like, okay, well, I have a square. This is 40. This is 40. I certainly have enough information. I have a squared and b squared to figure out the length of the hypotenuse. Well, if I figure out this length, okay, if I find c, all I got to do is divide it by 2, okay, and I will be in the center, okay? So that is the strategy. And matter of fact, let's go ahead and do that right now. Okay, so here is the work, all right? So a squared plus b squared, both of these sides is 40, so 40 squared plus 40 squared is going to be equal to c squared. So that'll be 40 squared, 40 times 40, 1600 plus 1600. We add this together, we got 3200 is equal to c squared. So to figure out what c is, we're just going to take the square root of both sides. So c is going to be equal to the square root of 3200. And we go into our calculators and we get c is approximately 56.56, okay? Now that's this distance right here. That's the entire hypotenuse, but we want to get to the center of the room, which will be halfway along that path, right? So all we got to do is just take 1/2 of our value of c, and that gives us about 28.28 feet. All right, so this is the approach that I would say that most of you that got this right probably took this approach, but a few of you that are just extra sharp in geometry probably remember this formula right here. Okay, now this is the formula that I was kind of alluding to in the beginning of this video. So this is a great shortcut, all right? And this has to deal with what we call special right triangles. Now before, you can see what I'm, the shortcut here in action, but let me just tell you what it applies to, okay? So there's two types of special right triangles that you're going to want to really know, and they're very, very important in math. I'm just sketching them out real quick. So the first is a 45 degree, 45 degree. Of course, this is a right triangle. This is 90 degrees. This is basically our situation, okay? The angles here in this square right here, we're splitting the diagonals, split this 90 degrees. So 90 divided by 2 is 45. So this is 45 degrees. Now that may not have been intuitive enough, but when you really study geometry, okay, you study things like polygons, squares, you learn additional properties that may not be so obvious, right? So when we have a square, the diagonal that goes from the corners of a square, that chops that 90-degree angle into two angles of 45 degrees. So this type of special right triangle is called a 45-45 90-degree special right triangle, and it's our situation in this particular problem. Now there is another special right triangle. Of course, this is 90, and this is a 30, 60 degree, 30 degree, 60 degree, 90 degree special right triangle. 30, 60 special right triangle and 45, 45. These two triangles have kind of shortcuts, right? They're kind of like little Pythagorean theorem shortcuts, but these are hugely important to understand, especially if you want to learn trigonometry. Now, I'm not going to explain that part of what I'm doing here, but math builds upon itself. Okay, so if you're like, oh, I'm just learning geometry. I don't need to know this. Well, yes, you need to know the Pythagorean theorem, and you need to know these shortcuts for trigonometry. Okay, now if you want to know why, if you want to study this more in depth, I'm going to leave links to my geometry course, my full geometry course, and my pre-calculus course. Okay, you'll find those in the description. And within my pre-calculus course, I really teach heavy-duty complex trigonometry. But let's go ahead and take a look at this particular formula for a special right triangle for a 45, 45, 90 special right triangle. Okay, so the formula is this, and this is the problem. This is the situation that we have. Okay, so this is a a square, okay, if these sides are congruent, this angle is 45 degrees right here, and so is this. Remember, the sum of the angles in a triangle is 180 degrees. Now, you may not have remembered that, but that's what it is. So this is 45 plus 90 is 180. Okay, so instead of doing a Pythagorean theorem, we can use this shortcut formula. So when you have this scenario, all we need to do is to take a side, right? And remember, these sides are congruent, okay, as well. Basically, we're talking about a square and simply multiply it by the square root of 2. All right, so let's just go ahead and test this. If we take 40 multiplied by the square root of 2, all right, for any square, when you want to find the diagonal of any square, all we have to do is use this little shortcut, a side times the square root of 2. In this case, it'll be 40 times the square root of 2. Take the square root of 2 in your calculator, you'll get this decimal approximately. So 40 times 1.414121 is approximately 56.56. Same answer, okay? So this is the formula for 45, 45 degree special right triangle. There is another formula again for 30, 60, 90 special right triangles. Not going to get into that formula in this particular video, but it's something that you do want to learn. Okay, so, in mathematics, you can continue just to kind of get, go into, more details and more details and more details. I have to stop myself sometimes because I just get so enthusiastic about just teaching, right? I'm like, I gotta stop myself because, you may not be as enthusiastic, but who knows? Maybe you are. But here's the deal. What I am trying to leave you with is, in my videos, is I'm trying to teach you something. I'm really trying to get you to comprehend a lot of the underlying concepts in a problem. Okay, so my videos are I like to think of them as more than just quick tutorials, right? I'm not I could show you how to solve this problem in like 30 seconds, right? That's not the idea. What I'm trying to do is to teach you some concepts that are important that can translate to all different sorts of problems in other areas of mathematics. Okay, with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.